In today's video, we're going to talk about some different types of energy. There are many different types of energy around us. There's sound energy, energy stored in matter, light energy, energy with motion. Energy takes many different forms, but for now we're only going to talk about three different types of energy: gravitational potential energy, kinetic energy, and elastic potential energy. This video will focus on the first two types of energy. Gravitational potential energy. Gravitational potential energy is the energy gained by an object from the Earth's gravitational pull. So here we have an object. This object is starting at the ground level. A force is applied to it by the hand, lifting that object up a distance h, or d for the amount of displacement. So first let's calculate the work done to move this object upwards, away from the surface of the Earth. We know we can calculate work by force times distance. That force applied will be equal to the weight of the object, or mg. That distance will be equal to h, how far it moved up. So now we see work equals mgh. And that is actually the same equation we used to calculate the gravitational potential energy. So that gravitational potential energy describes the amount of work done by gravity when an object is moved upwards. Potential energy means that that energy is stored away, or it may not be directly visible to us. So here we have the equation for gravitational potential energy. We see GPE equals mgh. Now, just like work, all of these energies are measured in joules. M is the mass of the object. Little g is the acceleration due to gravity. On Earth, we will be using 9.8 meters per second squared. Now, we do not have to worry about the negative sign for this. When we calculate the gravitational potential energy, we will be using positive 9.8. And h is the change in height. If the object moves upwards, the change in height will be positive. If that object moves downwards, the change in height will be negative. Now we know gravitational potential energy equals mgh, so we can easily find the mass. Little g, the acceleration due to gravity, we know, but how do we decide how to measure that height? We measure the height from ground level, or where h equals 0. Interestingly enough, we can really call any place we want ground level as long as we denote that. So we can call ground level where the bottom of the ladder is. We can call that h equals 0. Or we can call, let's say, that third step ground level. We can also say that is where h equals 0. So let's look at the two cases. The first case is when an object moves from ground level up to the first step. It's moved up a height of 0.5 meters. So the change in gravitational potential energy will be m times g times 0.5. Now let's say if we started an object at the third step, and again it moved up just one step, and it changed height of just 0.5 meters. So we see that gravitational potential energy, the change in it will be the same. It'll be equal to mg times 0.5. So in both cases we have the object moved up one step, so the change in gravitational potential energy was the same. So when we calculate gravitational potential energy, we always need to denote where we call the ground level, or where we say height is equal to 0. Let's try an example problem to calculate the gravitational potential energy. What is the change of GPE for a 5.0 kilogram object which is raised from the floor to a final height of 2.0 meters above the floor? I will let you guys try this problem. Now let's talk about kinetic energy. So if you have an object that is 1 meter above the ground, we know it's going to have some gravitational potential energy. Now let's say we let go of this book, we let go of the object, we know it's going to start falling down. And as it's falling down, it's going to start picking up speed, right? So as that object falls down, you may think, well, the h is decreasing, so that gravitational potential energy is also decreasing. That means it's going to lose energy. But actually, energy is never lost. What happens is that energy is just converted into a different form. So at the top, this book is going to have all gravitational potential energy. As this book falls down, it's going to lose gravitational potential energy, start picking up speed, and gaining energy in a form we call kinetic energy. Kinetic energy is the energy of an object in motion. Kinetic energy equals 1/2 mv squared. That kinetic energy is measured in joules. Little m is the mass of the object in kilograms, and v is the velocity of the moving object in meters per second. Let's talk about some relationships within kinetic energy. We see the kinetic energy is proportional to the mass of the object, so if that mass of the object doubles, the kinetic energy will also double. We see the kinetic energy is proportional to the square of the velocity, so if that velocity doubles, the kinetic energy will quadruple. Kinetic energy, let's look at the first example problem. A car with a mass of 1,300 kilograms is going straight ahead at a speed of 30 meters per second. The brakes can supply a force of 9,500 newtons. Calculate A, the kinetic energy of the car, and B, the distance it takes to stop. Let's start with just part A of this problem. We want to calculate the kinetic energy of the car. We know kinetic energy equals 1/2 mv squared. They give us m, the mass of the car, 1,300 kilograms. They give us v, the velocity of 30 meters per second. And now we can plug in both of those values, the mass and the velocity. And from there we can easily solve for the kinetic energy. Let's look at part B of this problem. For part B, we're trying to find the distance it takes for the car to stop. So in order to stop the car, the brakes must exert negative work on the car, and that negative work will decrease the amount of kinetic energy the car has. So we see the force that the brakes apply on the car is going to the right, and the distance the car moves will still be going to the left. So we see how that work is negative. And remember, negative work will decrease the amount of energy the system has, and for this problem, the system is the car. When that negative work done by the brakes is equal to the total kinetic energy of the car, that car will stop because it will have no kinetic energy left. The brakes did all this negative work and decreased that energy so much that kinetic energy finally goes to zero. So we can say the work done by the brakes will be equal to the kinetic energy of the car, or 585,000 joules. We know to calculate the work done by the brakes, that's equal to the force the brakes apply times the distance. They give us that force the brakes can apply. It says the brakes can supply a force of 9,500 newtons. So you can plug in 9,500 for the force. And from there we can easily solve the distance required to stop the car. So in summary, we learned about two forms of energy today: gravitational potential energy and kinetic energy. Gravitational potential energy is the energy stored in an object when it is at a height above the ground level. We calculate that as mgh. Kinetic energy is the energy of an object in motion. We calculate that as 1/2 mv squared. And all energies are measured in joules.